So our next speaker is Wim Godden. He has been working with open source technologies since 1997, and he has been involved in open source projects such as OpenX and PHPCompatibility. Next to web development, he has worked with a wide range of technologies, from database clusters to internet backbone design. Oh my God, I can't really comprehend all that. It's so complicated for me. And he focuses a lot on his time on highly scalable projects and coaching, training web engineers. So give your applauses for Wim.
Thanks. So today I'm going to be talking a little bit about stuff that's, well, a little bit outside of what you would normally expect at a PHP conference, although we'll discuss a little bit of PHP. We're going to look a bit beyond the code as well. So there was already an introduction, so you already know my name and my Twitter handle's up there. I'm from Belgium, for those of you who don't know where that is. It's the little dark green spot in the center of Europe. Of course, best known for beer and chocolate and other tasty, yummy things. And we have odd-looking buildings as well. In case you're wondering, this is an iron crystal magnified 65 billion times. And yes, you can walk into it. And I just read yesterday that apparently it has the highest toilet in Belgium. Not sure if that's noteworthy, but anyway. I live close to Antwerp. In my town, we have a beautiful abbey and a couple of castles, all very nice. It's not all good news, though. In Belgium, we also have a bit of a traffic problem. This is what happens when we have some snow. You get 2,500 kilometers of traffic in a country that's only 250 kilometers across. And smack in the middle of that, I started a company about 15 years ago. It's called Cube Solutions. Yes, we do have that fancy URL. And as the person who introduced said, I've been working with open source, various open source technologies since around 1997. And I've worked on projects such as PHP compatibility. If you don't know it, it's a rule set that allows you to check if your code is compatible with the next PHP version, or the previous one, actually. And I've been doing talks like these for last couple of years. I quickly want to tell you something about the company because it's going to be important along the way throughout the talk. So we do a lot of open source, mostly PHP, so we do Zen Framework and Symfony and Magento and a few other things. And we do some training courses on security and stuff like that. But we also do stuff outside of PHP. So we have our own high-speed redundant network on which we deploy customers and stuff like that. And we do a lot of stuff with high scalability. So we use Nginx, we develop on Nginx, we use MySQL cluster, we use Varnish. A lot of technologies that are a little bit beyond just coding. And most of our customers are IT or telco operators, a couple of governments, and so on. But we have a lot of public-facing apps, so a lot of sites that attract quite a few visitors. And it'll become clear why that's important throughout the talk. So that's enough about me and the company. Let's see who you are. Who here is a developer? Yeah, most of you. Anyone not a developer? Okay. So mostly organizers? Okay. Who has ever set up a MySQL master slave? Okay, a few. And I guess more hands will follow on the next question. Who has ever set up a site on a separate web server and a separate database server? Okay, keep your hands up. Do you know how much traffic runs between those servers? Yeah, not so many hands anymore. Okay, so you can see where I'm going with this. So we're going to talk about the stuff that is often, well, taken for granted, or those famous last words, yeah, it should work just fine. Also known as, it works fine on my laptop. So what works fine on your laptop today might not work as well in production tomorrow. So that's sort of the topic at hand. I'm not going to be talking about the most common mistakes. We've all made those. We've all learned from them, I guess. But I want to talk about PHP code and how it interacts with what we call the PHP ecosystem. Everything that connects to PHP, everything that talks to PHP. But of course, we're all developers, apparently. So it all starts with code. Now, what does our code interact with the most? What do we talk to a lot? Database, yeah. Our code interacts a lot with databases. So let's talk about databases. In fact, I'm going to talk quite a bit about databases, especially in the first part. I'm not going to discuss this. You should not be using a tool that generates queries like this. Does anyone know which tool produced this query? Any guesses? No guesses at all? It's one of my favorite all-time tools. It's called Drupal. I don't like seeing stuff like plus interval 0 seconds. Why would you do that? Add 0 seconds to something. So yeah, whenever you use a tool or framework that basically doesn't give you control over which queries you're generating, you get stuff like this. You're writing a module, you're writing a plugin on top of it, and it just produces something, and you have no clue what it's doing. It could produce 1,000 queries per page, and yeah, no control. So I'm not going to discuss the complexity and why you should not be doing that, but I want to touch on database indexing for just a bit. Indexes make databases faster in general, and most people think they know a lot about indexes because they create some indexes, primary key, and they put an index here and there, and so yeah, it just works and makes it faster. But I have a little quiz. So we have a query here, select ID from stock, where status equals to order by quantity. I want to place the right indexes on my stock table. Which indexes should I put on there? I hear a lot of different things. Someone raise your hand. Yell it out. Status and quantity. So 2 separate indexes? 1 index, yeah. You want to create, in this case, an aggregate index on status and quantity. That way, when this query runs, 1 index lookup is going to be sufficient to get the entire thing. But what if I do this? Is it still the same? Now you might think, no, it's probably not going to be the same, but this might be a trick question. Anyone have any idea? The same? The same, okay. Well, the answer is, it depends. Because if you use a B-tree index, then yes, it's the same. You can still use the aggregate index. If you use a hash index, then as soon as it encounters that greater than sign, it's going to ignore the rest of the index. So in that case, you need 2 separate indexes. But then that only works if you use MySQL version 5.6 or higher. So this is just to illustrate it is actually important not just to put indexes wherever you think they might be useful, but to actually put them on the right spot and to use the right index, and even to know which version of the database server you're going to use in production, because that's going to affect your performance as well. So as I said, indexes make databases faster. Some people say, okay, you know what, let's just index everything. So I have 20 columns in my table. I'm just going to put 20 indexes on them, and then I'm going to create aggregate indexes across them, and so on. You might not want to do that, because every time you do an insert, an update, or delete, whatever modifies your database, it's going to have to update every single index in there. That's going to take a long time. Plus, every single select that you do, the database server is going to look at all the indexes and say, which one should I use? It's not actually going to go through the indexes, but it's going to evaluate which one would be the best to use. So that takes time as well. There's a good quote by Bill Carwin, the author of SQL Anti-Patterns, a very good book, by the way. And he says relational schema design is based on data, but index design is based on queries. So basically that means when you're designing your application, you look at your data, all the data that you have, that's when you're going to build your table structure. That's your relational schema design. But then you're not actually adding any indexes other than your primary key and your foreign key. Only when you're actually writing your code, when you're actually writing your queries, that's when you add the indexes, just the ones you need. That way you have just the right amount. Okay, so let's imagine that we have an application, it's been running for 5 years, and there's some performance issues, and we want to find out which queries are causing issues. How do we do that? Well, there's a couple of ways. I'm talking mainly about MySQL, but for almost everything, there is a similar functionality or command in Postgres or Oracle or even Microsoft SQL Server. So on MySQL, you can turn on the slow query log. You do that by setting global slow query log equals on. And what it will do is it will output all queries slower than a certain amount of time. And you can change that amount of time as well. On Oracle, you can do that using a query that you can run, and it will give you output of which queries have been slow. There's another flag that you can turn on in MySQL. It's called log queries not using indexes. Now, what would that do? Obviously. Now, there's a caveat here. This one will only work if you enable the slow query log. That's not very well documented, but if you turn it on without enabling the slow query log, you're going to get absolutely no output at all. Then there's another one, and I really like this one, the general query log. If you turn this one on, don't forget to turn it off, because this is going to log every single query running on your system. That's okay if you have 5 queries per second. It's not so good when you have 30,000 queries per second. That might actually overload your server to the point where it basically goes down. Now you might wonder, why would I ever log 30,000 queries a second? Why would I need to log every single query running on my system? Well, the nice thing is that there's a toolkit called Percona Toolkit, which has a tool in there called PD Query Digest. Now, if you take that log file, that general query log file, and you run it through that toolkit, then it will produce output that looks a little like this. So it will show you which queries are running most often, and it's going to aggregate actually the queries that are very similar. So it's going to look at the query and say, okay, these queries look the same except for the parameter. In one case it's 5, in the other case it's 7. And it's going to list those queries ordered by the time spent running on a database server. So in this case, we have one query that in total has taken 16,000 seconds, which might be okay, except for the fact that it's taking 13.6 seconds per query. So that's not a very good and efficient query, of course. The others are very fast. They take less than, well, 0.0001 of a second, so that's very good. We can safely ignore those. Now, you might think, okay, this is useful information. Is that all? Well, no, because I couldn't fit it all on the screen. Per query, below this, you get output that looks like that. Now, I'm pretty sure that's unreadable at the back, but basically it'll tell you how much time was spent logging, how much time was spent examining the indexes, and so on and so on and so on. So if you really want to dig deep into how the query was run, you can find out about every single query on your system. So now that you know which queries take a long time, you can actually examine them a little bit closer. In MySQL, you can do that using the command explain. So you just type explain, and you type the query up behind it. And what it will tell you is how MySQL will run that query. And it will produce output a little like this. So in this case, we have a very simple query on the employees table. And you can already tell that the possible keys here are null, which means there are no indexes on that table. That's a very bad sign. So obviously, it's not using a key, and it's reading almost 300,000 rows. Not a very good idea. If we run explain on a different query, it might produce output like this. We have a join here between 2 tables, and it actually can use a primary key, and it is using a primary key, so it's only reading 1 row per table. That's very efficient. There's 2 columns here, type and extra, that give you extra information. When type says system const or ref, that's very good. If it says all, like it did right here, then it basically means it's reading the entire table. It's doing a full table scan, which is a bad sign. If in the extra info it says using index, that's good. If it says using file sort, unless the table is very small, it's usually a bad sign. Okay, enough about indexes. There's one thing that we come across at customers quite a bit, usually in older code, but still, sadly, in modern code as well. It's called the N+1 problem. Basically, it means we do a lookup. For example, we're going to look up in customers. This is using some kind of ORM system. We're going to filter by state on Minnesota, I think this is. And then we're going to get all those customers back, and then we're going to loop over the customers to get all the contact information for those customers. This works fine if you have 5 customers. If you have 1,000 customers, this means we run one query to get all the customers, and then 1,000 queries to get all the contacts. Not very efficient. The solution, I'm sure most of us know it, is doing a join. Either doing it like this or in the ORM way. Now we're running one query and we're fetching all the same information. So 10,001 queries to one query, yeah, it's better. Sadly, a lot of people still do this all the time. And there's mainly two reasons. First of all, as I said, they have 5 customers, so they don't see it as a problem. You know, I'll just do a for each loop here. But then the company buys another company, and they have 10,000 customers, and now it is a problem. And the second one that we see is it's an internal app, so it's being used by 2 people, so it's not really an issue. And then at some point, the manager comes along and says, that's a nice app. I'm pretty sure our customers would love it. Let's put it online. So now you got 1,000 people visiting that same app. So why did I start giving this talk? Well, basically, I said we build code for customers, we implement projects, but we also get dragged into stuff, usually to fix issues or to do a migration to a newer PHP version and so on. So this is sort of like 15 years of how to cause total havoc with 2 lines of code. And I want to illustrate that with a couple of customer examples, just because it's always fun to laugh with customers, right? Of course, I can't mention their names, although I would love to sometimes, but so I'll call them X, Y, and Z. So client X had a job search site. So you went on that site and you were looking for a PHP job, you would type PHP, search, and you would get a listing of all the PHP jobs in the system. And then you could click on it and view the details and maybe contact that company and see if you can get a job with them. And they would monitor how many times a job was viewed on a daily basis, a weekly basis, a monthly basis, and then they would also monitor which users saw which job. And they had a table structure that looked like this. So they had shown today, shown week, shown month, and then shown user, and they had primary keys on the job ID, and the number was logged, and then on the shown user, they had a job ID, a user ID, and a timestamp. And there's different ways of implementing it, but this actually worked, and it worked pretty well, and they would reset the today count at midnight and the week count on Monday morning, and so on. Working just fine. And originally, they would log whenever someone actually clicked on the job and saw the full description. But then for some reason, the marketing or salespeople decided, we want to change that. Now we want to know when someone sees the job in the search result. Not much of a difference, is it? Except that now when you type PHP and you click search and you get 50 jobs, it means those 50 jobs have to be updated. Which means 50 updates for shown today, 50 for shown week, 50 for shown month, and 50 inserts for shown user, or 200 queries for one search. Now, this was the code they were using before that. Might be a little small at the back, but basically, it's actually pretty good code. It's doing an insert into shown today, it's inserting the job ID and the number 1. Or if that record already exists, it's going to use unduplicate key to increment it. So that's pretty efficient. Works quite well. Shown week, shown month the same way, and shown user, it just inserts it. Now, I mentioned they wanted to be able to log it now whenever it's being shown. So what do? Well, they just added a for each, right? That's easy. So now you've got 200 queries running per job search. Now, we hadn't built any code here. We just set up the MySQL master slave. And this is the graph of the master. And as you can tell, we set it up somewhere around August 20, and everything was going fine. I don't know what that is, but everything was going fine, and then suddenly they made that code change. And you can tell something's really different here. There's a lot more updates. There's quite a few more inserts as well. But the thing is, they were doing up to 1,600 inserts, up to 2,600 updates per second, but they had a 16-core machine, and it was handling it perfectly fine. No issues at all. And we set up MySQL enterprise monitoring on it, and no mails about anything, any warnings or anything. Everything was fine. Until the client calls us really panicking, because he had just received a mail from the monitoring system saying, the MySQL slave is now more than 5 minutes behind the master. Okay, that's not good. We set it up, so who do you think they blamed? Yeah. So we went in there and said, okay, hang on. Something's not right. What's causing these peaks? We didn't change anything in the infrastructure, so what's happening? So we asked the developers, did you change anything? And they said, nah. Okay, fine. So what do you do? I mean, the graph shows something's wrong. The monitoring system tells us something's wrong, but the guys didn't change anything. So we did turn on the general query log and run it through pdquery digest. And what do we see? Well, we have 4 queries that are now at the top. A query about shown today, shown week, shown month, and shown user. So we went back to the developers and they said, well, maybe we made a tiny little change. We added this for each thing somewhere. Yeah, okay. So after 3 days, the slave was lagging 2.5 days. And every hour we added 50 minutes. And the manager said, yeah, it's fine, it'll catch up during the night. No, it won't. And he said, well, maybe you can tweak the server in such a way that it will catch up during the night. And we said, well, maybe we could try, but what's the point of having master, slave, if when your master crashes, you cannot use your slave because you need to wait 2 hours for it to catch up? So there's really no point in doing that. The big question is, why is the slave lagging? So to understand that, we need to look a little bit at how master-slave works in MySQL. So, and in most databases, actually. So the master can execute all the queries on 16 cores. It's probably going to use not all 16, but quite a few of them. And it's executing those queries, and whenever it writes it to disk, it's also going to write the query to a binary log file on the local file system. It uses 1 CPU to do that. And then the slave is going to copy that file to its local file system using 1 CPU core. But then it has to execute those queries in the exact same order. Otherwise, it's not going to be in sync anymore. So the only way to do that is to execute those queries sequentially, meaning it can use 1 CPU core. Now, the master can use 16, the slave can use 1. Yeah, that's not a good sign. So the master looked like this, and you can see it's okay, and then it goes up. The slave looked like that. So although you see color change, it's not really going up a lot because it was just maxed out. It was very close to being maxed out before, and now it really is. So how do we fix this? Any suggestions? Sorry? A single update. You mean 1 query for the entire thing? One table, yeah. Sorry? You could theoretically put it in 1 table. It's going to be a giant table, and it's going to be a pain especially to reset it every week, or you'll have to keep all the data all the time. Sorry? So there is an easy solution for it. What you can do is use an extended insert. So instead of having 50 inserts for shown today, you just group them all together. And you can still do onDuplicate key, and then that onDuplicate key will work on each insert individually. So now you have 4 inserts instead of 200. That's an improvement, definitely. So we told them, look, try it this way. Told the developers, use this system. And they started working on the code, and they produced this fantastic piece of code after 3 days. So they did insert into shown today, and then they still do a for each here, but that's okay. That's in pure PHP, and then they add the job and just append to the string. And then, of course, they have to cut off that last comma and then add the on-duplicate key. Now, this works, but we couldn't wait for 3 days because the slave was lagging behind. So we opted for a slightly different solution. We just said db autocommit false, and then db commit, basically telling the database server, OK, you're going to execute 200 queries, live with it. But instead of executing a query and writing it to disk and updating the index, and then executing the next one, and doing that 200 times, you're just going to execute all the queries simultaneously, write to disk once, and update the index just once as well. And that's something that the slave could actually handle on one CPU core, because it doesn't have to write to disk all the time, and it doesn't have to update that index all the time. So, conclusion, we knew for loops were bad. The issue is that if you have for loops today in any piece of code and you're like, yeah, it's okay, it's not causing a performance issue, if your DBA at some point decides he wants a master slave, then that might be an issue, because the slave might not be able to cope with that. Using transactions, yes, it will, in cases like these, improve performance, but it could also introduce locking issues. So you have to be a bit careful there. Better yet, better solution, use MariaDB 10 or higher, because it has a feature called slave parallel threads that allows you to run more than one, run the replication on the slave on more than one CPU core. So that's very nice. MySQL still doesn't have this. In our case, the slave caught up about 5 days later. We haven't heard from the customer since, so we're thinking they're still okay. So we talked quite a bit about the database. Let's talk about stuff that PHP talks to as well, which is the network. So we had a customer Y. They had a pretty big site, one of the top 10 sites, and they were growing exponentially. The funny thing is, between 8 and 10 in the evening, they would get database connections dropping out, errors, weird, inexplicable things were happening. And they couldn't explain it because the load actually on their servers was very minimal. And we hadn't written any code there, but they couldn't figure it out anymore. They called us and they said, can you figure it out? Can you have a look? So we went in there and we said, yeah, sure, we'll have a look. We'll give it a try. And so they had a database server connected to a switch and a web server connected to that switch. And we said, do you have any monitoring tools? And they said, well, we can see if the servers are live. So we installed a tool called IPTraf. Anyone know IPTraf? Yeah, a few people. OK. Basically, it's a tool that sits on a server, and it just tells you how much traffic is going across the network. Turns out they were sending 98 megabits per second from their database to the web server. And their switch here was 100 megabits. 98 plus a little bit of overhead, yeah, that's 100. So we told them, look, this is your problem. You know, there's a switch here, 100 megabits, and it's just maxed out. And they said, great, thank you, gigabit switch in there. Thank you very much, send us the invoice. We said, yeah, we'll send you an invoice, but hang on just a second. Why are you sending 100 megabits across the network? Your site is not that big. So it turns out they were sending 700 gigs per day from the database server to the web server, and then they were sending out 60 gigs a day to the web. Now, something doesn't really add up here. I mean, why would you retrieve 700 gigs only to send out 60? And it turns out they were using one of my favorite tools called Drupal. Is Larry here? He left the room, OK. So Drupal has a system called hooks. I don't know how it works in Drupal 8. This was on Drupal 6. It has a system called hooks, so you can hook into content blocks and stuff like that. And it will basically run code, like retrieve queries. And then at the end, it could decide, I don't need it. And it will just throw away the data. So the takeaway of that, of course, is only load data that you're actually going to need. And if you don't know which data you're going to need, well, use lazy loading. Load it the very moment you actually are going to use it. Now, you might think, oh, I'm using Memcached or Redis, so no problem, it's very fast. Yeah, but you're still transferring it across the network. And it's not just transferring it across the network. You're receiving it in PHP, which means you're storing it in memory somewhere. You might be doing other stuff with it, even parsing it or something. So you're wasting a lot of resources there. Now, if we look at the network, it's not just too much traffic that can cause issues. We had a customer, Z. They had around 150,000 visits a day, which at the time was quite a bit for a Belgian site. And they had a news ticker. Well, it didn't actually look like this, but if I showed you the real one, you might know which company it is. And they were retrieving an XML feed for that news ticker from a site that they also owned. But they didn't want to hit that XML feed every single time, so they would cache it locally for 15 minutes. And this is the fantastic code that they wrote to do that. So what they do is they check the creation time of a cache file and check if it's more than 15 minutes old. Then they will delete that cache file. Then they're going to do a file get contents of the original feed, use a file put contents to put the cache file back, and then finally they're going to parse the XML feed and do something with that variable. Can anyone tell me what's wrong with the code? Or what's not wrong with it? But sorry? Yeah, so if the cache expires, many people are going to go in there. We'll get back to that one. Okay, another one? What else? Sorry? Yeah, we parse the file every time. We'll get back to that one as well.
It takes several seconds to get the content, and until that second, everybody goes to get
Yeah,
the content.
yeah. So it takes quite a while to do this file get contents maybe, and everybody's doing the same thing then at the same time. These are all true. Sadly, that's not what happened. It's a little worse what happened. So I told you they owned the other site. Now, this server at the feed source, this server at the site, and that data center lost power. So no source anymore, no XML file. So for the first couple of minutes, everything was fine until the cache expires. Now everyone's doing a file get contents of that cache file. What happens if you do a file get contents of something that's unreachable? You're going to get a timeout. What's the default timeout in PHP? 60 seconds. So now everybody is waiting 60 seconds for a page to appear. Really? Waiting? No, refresh. New tab. Damn, my Firefox is hanging. Let me open Chrome in that. So you get more and more connections. Until at some point they were using Apache. Apache hits the limit. And now it's not just the page containing that feed, it's the entire site that collapsed. So we get called and they're like, we don't know what's going on. We log on to the server and we see 400 Apache processes taking 0 load. They're just sitting there. And we're like, okay, no idea, let's restart Apache. 50 seconds later, same thing. 400 Apache processes, 0 load. So it took us a while to figure it out. And then we, of course, disabled that feed so it wouldn't show up anymore. And we told the developers, look, fix your code. And we told them it's not urgent now because the feed is offline for now, but just fix it. And this is the fix they came up with 2 or 3 days later as well. This is their fix. So they created an HTTP context with a timeout of 5 seconds and applied that. Yeah, that's a fix. Now people don't have to wait 60 seconds, they have to wait 5 seconds. Okay, anyway, let's look at the other things that were mentioned here. So first of all, that unlink here. Yeah, it's a very bad idea to go into that if structure and then do an unlink, because as soon as you do the unlink, the file is not going to exist anymore, right? But if you have 50 people going into that if structure and doing the file get contents, and then doing file put contents, then someone might actually do file put contents, and a fraction of a second later, someone might do the unlink again. So everybody's going back in the if structure now. So let's just get rid of that unlink. Another thing is that we have a bit of an issue if you do file get contents and you get a timeout. What does file get contents return? False. So we're actually putting false into our cache file. That's not going to parse very well. So we need some way to handle that. We need to check if the return of that is false and so Another thing that was mentioned, we don't want to be doing parse XML feed over and over again. How about we parse it once when we do the file put contents? And there's one more thing that wasn't mentioned. If you look at this code, file get contents and file put contents are actually not atomic operations in PHP. That basically means if you have one person doing a file put contents and someone else doing it at the same time, that's going to corrupt the file. Or if someone's doing a file put contents and someone else is reading from that file, that person might read a partially completed file. Because PHP will by default not lock the file operation. So if you're relying on the user to execute this code, you might get corrupted files. So the best way here, of course, is to run this every 15 minutes through a cron job and just fetch the feed every 15 minutes. So the lesson learned from this experience was use timeouts for everything, every single operation, and don't rely on the default timeout of 60 seconds because it's just not good enough. And if, in fact, your data source is trusted, like in this case it was, they owned the other side, why not reverse the process? Why not have them push the news to you instead of going and fetching it every 15 minutes? If the news doesn't change for 2 years, you're still fetching it every 15 minutes. Add logging. We should know about this. You should know when something goes wrong, when you get a timeout, when the URL is not available, when the cache system doesn't work. You should know about it. And speaking about logging, good, very good. Logging in PHP using fopen, yeah, not so good. You might get either you get file corruption or you get locking issues or something like that. Is anyone using Monolog or a similar system? A few of you? Okay. Monolog is a very nice system. It allows you to log to these and plenty of others. You set it up once, and then it's very easy to switch from logging to a file to logging to Graylog, logging to Elasticsearch. All you have to do is change the configuration without any code modifications. Who's using Firefox? Okay, who's using Firebug? Okay. There's a plugin for Firebug called FirePHP, which allows you to write from your code directly into Firebug without your users actually seeing anything. I always say don't produce any debugging output on production, but if you really have to, then that's probably the best way to do it, because that way your users won't see it. You can actually do it even on AJAX requests. Keep an eye on your logs. Who opens their logs at least once a week? That's not a lot of hands. Yeah, I mean, having logs is kind of pointless if you never open them. So watching them is important, but it's also important to watch the actual logging process. A lot of database administrators will put their databases on fast SSD drives and their log files on old 5,400 RPM disks. That's fine as long as you don't get a lot of stuff being pushed to the logs, but this might actually cause an I/O bottleneck. And speaking about I/O, well, there's two causes, of course, excessive reads or excessive writes. Writes could be database updates, log files, or swapping if you don't have enough memory. Reads, well, if your indexes are not properly defined, or if your file system cache is not properly defined, could cause issues as well. How do you detect it? Well, if you're running, who runs Windows production servers? Nobody, thankfully, thank you. So if you're running Linux, you can just type top, and then it will tell you all the processes running. But at the top of top, it will say something like this: CPU using 0.2% usage and so on. And then it will say 35.5% WA, which stands for I/O wait. Basically means my system is waiting for the disk to return me something that I'm reading, or I'm waiting for the disk to write something. 35.5% of resources being wasted, basically. And then you can type IO stat, and here it will say the IO wait is now 53.7%. Half of the time spent is spent waiting. And then it will tell you, okay, I'm doing that on this device. And you can drill down even further until even the process and the process ID, specifically what it's doing, reading and writing. If you see IO wait higher than 10% nonstop, stop worrying about your code. Fix this problem first. because this is what's dragging down your site, not an issue in the code. So we talked about a lot of stuff outside the code. We talked about stuff that happens on the database server, like indexes. We should know which indexes to use. We should know what a query is doing exactly on that database. But also external stuff like an XML feed. Our code talks to external things. It's going to fetch stuff. What happens if that thing is not available? Or what happens if that XML feed is badly formatted? Does our code handle it? If we write code that talks to external services, it should be able to handle that. We talked about the network. And it's not just about too much traffic. It's also about timeouts. It's also about the network being slow for some reason. What if that XML feed can only be retrieved in 20 seconds? Will the user have to wait for that? Then there's the web server. That's PHP, of course. There's plenty of talks about PHP, and PHP 7 is going to improve performance on that as well. And then there's the user. I didn't talk about that, but you can cache stuff in the browser, or you can gzip stuff. There's a lot of stuff you can do there as well. So it's not just about the elephant. It's about the penguin, and it's about the dolphin. It's about the devil, if you're using FreeBSD. It's about all those different things. Because if you just look at the elephant, you're just looking at your code, then you'll be a great PHP coder, typing code all the time. But if you don't know and look at how your code interacts with all the things that surrounds it, then you're just going to be stuck in that PHP coder atmosphere the whole time. So try to open up and try to look at all the other stuff and become a true PHP engineer. And with that, any questions?
What about analyzing the issues with the network? In your example, it was between the PHP server and the database server. How can we analyze any issues there? Any tools that you may recommend about finding issues there? For example, if you may have good performance between server A and server B. Let's say server B is the MySQL, but you may have bad performance between server C and the same server, database server B. How can you find what may cause this issue?
Right. Well, the first thing to do, of course, is to set up proper monitoring. I think it goes without saying that if you don't have any statistics, if you don't have any graphs that show you the load on each system, and not just CPU usage, but load, meaning taking into account the I/O weight as well. If you don't have statistics like that, then you're basically blind. You will not be able to tell what's going on. Your site might be slow, your app might be slow, but you have no clue where it comes from. As soon as you have some graphs that will tell you, okay, my load on that system is high, that's the first place you should start, really. And then there's sort of a golden guideline of steps to take. First, look at I/O on the database server, then look at I/O on the web server, then look at general CPU load on the database server, which might point out the issue is index related. If that is all fine, then look at CPU on the web server, in which case it's usually PHP related. So that's sort of, I think I even have a slide on it. There you go. Oh yeah, the first one is use NFS, get rid of it, but oops, that was one too far.
Actually, my question was really regarding network issues.
Okay.
Only regarding network issues, because everything else is fine.
Regarding network issues, it depends, of course. If it's high load on the network, for example, that again should show up in your monitoring. If it has to do with timeouts, that's a little trickier.
Anything you may recommend about monitoring and finding network issues?
Yeah,
any
yeah.
kind of tools that you may recommend?
Yeah, so having a monitoring not just on your servers but on the network is definitely a must, really. Including things like monitoring for drop packets, monitoring for transmission errors even. Because what we often see is issues with hardware, really, which don't show up until you hit a certain, like 50 megabits per second, and then all of a sudden, packets are being dropped, you get transmission errors and stuff like that. And monitoring is really the only way to figure that out.
I think what he means to ask is specific examples of monitoring tools.
Oh, you mean specific examples of monitoring tools? Okay, there's a whole bunch of them. There's Libre NMS, for example, is a very nice tool to do that. Of course, the most obvious one is Nagios. That's sort of like the tool that everybody uses to see if servers are online, and that will do proper reporting as well, even text messaging and stuff like that. I can add a few to the slides. I will put the slides online anyway, and I can add a few there that you can reference then. Yeah, go ahead.
Hi. You were talking about how transactions improve performance of MySQL, but you said they have cons. Like, what are those?
Well, I think transactions definitely help in terms of performance because they group the queries together, especially if it's insert, update, select doesn't really matter. They group them together so that you have only one write and one index update. The downside is that if you put a lot of stuff in there, transactions can also place a lock on those rows or even on an entire table in some cases. And that could introduce serious lock contention, basically, which means your row will be locked, and if something else tries to write to that same row, they will also be locked at that point. So if you try to update the same row 1,000 times at the same time, you're going to get issues. That's probably the biggest issues you can have with transactions. I don't know how much time I still have. Out of time. I will definitely put up the slides. They will be on Joined-in as well. Feel free to provide some feedback there. Tell me what you like. Tell me how I can improve the talk. And I will link the slides on there so that if there's anything you want to go through again, you can.
So I'm sure you guys have more questions for Wim, but you can find him in the hallway, I'm sure. Grab him and talk to him about all the stuff he mentioned. So let's give him a round of applause.